Common Core State Standard Support Video in Mathematics. The standard is 7RPA3. This standard states, use proportional relationships to solve multi-step ratio and percent problems. Examples, simple interest, tax, markups and markdowns, gratuities and commissions, fees, percent increase and decrease, percent error. Let's look at some of the related standards to this one. In the grade before, in grade 6, there's standard 6RPA3C that talks about finding a percent of a quantity as a rate per 100. Now notice that they do use the idea of percent. Now, other than 3 high school standards, 7RPA3 and 6RPA3C are the only standards where the term percent is specifically addressed. Topics such as simple interest, tax, gratuity, and so forth imply the use of percentages even though the term percent is not explicitly stated. Back in grade 4, students convert fractions with denominators of 10 and 100 to decimals. In grade 5, the focus is mostly on using decimals with the 4 operations. And in the grade preceding this, grade 6, the term decimal does not appear in any standard. The number system focus at that grade level is rational numbers, including integers. In order to succeed with the problems posed by this standard, students have to be proficient with conversions among fractions, decimals, and percents. Now, there is standard 7NSA2D that talks about converting a rational number to a decimal using long division. And they need to know that the decimal form of a rational number terminates in zeros or eventually repeats. We have this idea of knowing how to convert from one form to another, decimals, fractions, and percents. When you look at converting decimals to percents or to fractions, what we're dealing here is computation. So for computation purposes, it's really about the relationship between fractions and decimals or percents and decimals. If you're talking about the direct connection between fraction and percent, that's really more about fluency. For example, students need to pretty much have ingrained that 1/4 is the same as 25%, or that 3/4 is the same as 75%. So students have to have a conceptual understanding of this relationship between fractions and percents. Again, they need to be able to recognize pretty quickly that 18% is the same thing as the fraction 18 over 100. Let's focus on this idea of using proportional relationships to solve multi-step ratio and percent problems. In 6th grade, you had standard 6RPA3, and in 7th grade, you also have standard 7EEB3 that talks about solving multi-step real-life and mathematical problems. This standard 7EEB3, the big difference is that it deals with a variety of numbers. It deals with whole numbers, fractions, and decimals, again, numbers in any form, and students have to convert between forms as appropriate. This idea of using proportional relationships. Now, it's not necessary to set up a proportion to solve these problems. However, the general equations used to solve these problems can be derived from a proportion. Let's start off with this ratio. You have some original amount, and that's 100%. And then we set that up equal to some new amount over 100% plus the percent change. Now, this is for context where there's an increase from the original amount. And notice the plus sign. It's 100% plus the percent change. So, for example, if we had a 12% increase, then it'd be the new amount compared to 112%, which came from 100% plus the 12% increase. Now, if there's a decrease from the original amount, then it'd be 100% minus the percent change. So, for example, if we had a 9% decrease, then the proportion changes to the original amount compared to 100% would be equivalent to the new amount compared to 91%. It might be easier to think of the 100% as 1. So that converts to the original amount compared to 1 would be equivalent to the new amount compared to 1 plus whatever the percent of change was. Now let's take this proportionate and do some manipulation with it. Let's multiply both sides by 1 plus the percent of change. When we do that, this is what we get. The original amount times 1 plus the percent of change would be equivalent to the new amount. And if it's for a context where there's a decrease from the original amount, then it'd be 1 minus the percent of change instead of 1 plus the percent of change. Now, when we do the computation, we're going to have to make that percent change into a decimal. Again, for computational purposes, we need to have that percent change in decimal form. And in the case of a decrease, it'd be 1 minus a percent change instead of 1 plus the percent change. This equation, notice again that it came from our proportional relationship. We derived it from that. So it didn't come out of thin air. You know, there is a justification for it, and we can show this. And it's best to do this because students will understand, you know, that, again, this came from somewhere. And it came from this idea of a proportional relationship. Now, we can express this relationship the way we have it originally, but we can use our distributive property and tweak it just a bit. If we use our distributive property, we have this expanded version that will be the original amount times 1 plus the original amount times the second term in that parentheses, the percent of change, and that will be equal to the new amount. Now, the original version of this that we came up with, this form has the advantage of less computation. Students don't have to take as many steps. But there are some situations where the expanded version might make more sense. If you look at the second part of this on the left-hand side of the equal sign, the original amount times the percent of change, that actually gives us the amount of change, the actual amount that changed from the original. Again, although it involves additional computation, you know, the second form of the equation provides the actual amount of change if it's something that is asked for in the context. Okay, let's look at these different types of problems. Simple interest. Let's take this context. Monica has $500 in a savings account where she earns 3% interest per year. What's her new balance after 1 year? Well, we have an option of which form of this relationship to use, and let's go ahead and use the longer version, the expanded version that we use the distributive property. So we're going to have our original amount times 1 plus the original amount times the percent of change equal to the new amount. Now, we don't really need the 1 because that doesn't change anything, so we can get rid of that. It would be a good idea to use this as the template until students become proficient with it, then move on to the use of variables. But if you leave it in this form, it's a lot easier for students to figure out where it is that the different numbers should be placed. In this context, the original amount was the $500 that she had in her savings, plus the original amount, which is still $500, times the percent change, which was 3%, and that's going to be our new amount. We need to change the percent to a decimal for computation purposes, so that becomes 0.03. So now we have 500 plus 15 is equal to the new amount. So the new balance is $515. Well, what about that shorter version of this relationship? The original amount times 1 plus the percent of change is equal to the new amount. Let's try that. So 500, the original amount, times 1 plus 3% is equal to the new amount. We need to change the 3% to a decimal. Then 1 plus 0.03 is 1.03. Do the computation, and we get the new balance directly, being $515. Notice that with this method, using just 1 plus the percent of change, again, it's more direct. But students need to understand what's going on here. You know, what really happens, you know, when you have an increase of 3%? Well, we have 1 plus the percent of change, which in this case was 3%. We change the 1 back to 100%. So we have 100% plus 3%, which is 103%. And as a decimal, that converts to 1.03. So 1.03 is a shorter way to represent an increase of 3%. Again, you get the new amount directly by multiplying, in this case, by 1.03. Now, what if you had a decrease of 20%? So now you would have 1 minus a percent of change. But let's go ahead and change that to all percentages. 100% minus the percent of change. Plug in our numbers. 100% minus 20% being 80%, which is 0.80 as a decimal. So a nice, easy way of representing a decrease of 20% is simply by multiplying by 0.80, because that is what you have left, 80%. Let's look at another example, this time using tax. Jesse bought a new car for $24,000, but must pay 6% sales tax. What's the cost of the car with taxes included? Now, they're not asking us for the actual amount of tax, so we can actually go straight to the solution and use the shorter form of the relationship. The original amount times 1 plus the percent of change is equal to the new amount. So we plug in our numbers. The original amount was $24,000. 100% plus 6% equals to the new amount. So we have 24,000 times 106%, which converts to 24,000 times 1.06. So we get directly that the total cost of the car is $25,440. Now, let's say the context was a little bit different. Instead of asking directly for the cost of the car, with the taxes included, what if the question asked for the amount of sales tax? Now, if we take the expanded version, the actual amount of sales tax is going to be given by this, by the original amount times the percent of change. So that's really all we need. We don't need all the rest of it, because all they want is just the sales tax amount. So the original amount times the percent of change would be the actual amount of change. So here's a slightly different form that we derived, where if we're looking for the actual amount of change, it's going to be the original amount times the percent of change. In this case, it's the sales tax. The original amount would be the price, so we're going to take our price of $24,000, multiply that times 6%, because we had a 6% tax rate, and that's going to be the actual amount of sales tax. So change it to a decimal, so we have 24,000 times 0.06, and so we come out with $1,440 for the sales tax. Let's change the context one more time. What if they wanted to know both things? They want to know the sales tax and the total cost of the car with the taxes included. Well, we could do it with the shorter form of the equation. By doing it this way, we're going to get just the total cost of the car. But all we'd have to do is take the total cost of the car minus the original price of $24,000, and that would give us our sales tax, $1,440.